My pleasure and honor to introduce Dr. Mark Renz, an extension weed specialist here at the University of Wisconsin-Madison. He does most of his research in the biology and management of weeds in perennial cropping systems and natural areas. Mark has over 15 years of experience conducting weed management research throughout the United States. With that, please help me welcome Dr. Renz.
Thanks, Jeff. It's a pleasure to be here today, and I have two goals in this session, in this presentation. The first and most important is to get you out early so you can get in the front of the lunch line, because I'm sure it will be a long one. And then the second, I want to just kind of talk about when we're developing weed management and utilizing a burn down program, some simple concepts that you can utilize to potentially improve control, particularly with some of your perennial weeds that you have in that system. But first, let's talk about why do we do burn down treatments? You know, what's the ultimate goal? And I have several split up here, but I want to emphasize, the number one goal of our burn down treatments is what? It's simply to prevent that early season competition during that crop emergence and establishment. And just remember that, and I think in general we do a pretty good job with our burn down treatments in accomplishing that one goal. But there are also some opportunities to get some enhanced weed control. Some of it will come at an additional cost from our burn down treatments. Some of those additional benefits may be some additional weed management. We can use some herbicides in our burn down treatment that have residual activity that can delay weed development, that could particularly allow us to delay some of our post-herbicide applications and maybe reduce some of our weed population densities. But from a weed perspective, some of our opportunities really are this is an opportunity to reduce and manage some of our weed populations. Now, I was tasked with focusing on perennial weed management and how we can increase some of our weed management from on perennial weeds with our burn down treatments. But I'm also briefly and initially going to talk about winter annual weeds. So why did I change and add this topic onto our system? Well, I want to first remind you guys what a winter annual weed is. A winter annual weed is one that is going to germinate in fall to the early winter. And what's going to happen is when springtime hits and everything gets going, those are going to be really widespread, flowering, and very troublesome and very competitive. And here's a great picture that was taken by Jerry Dahl showing in early May we can have a carpet of weeds that can be extremely, extremely competitive. Well, why am I talking about winter annual weeds when the title has perennial weeds in here? Because I expect large populations this spring. Remember how nice and pleasant it was in October? Well, what happened during that time frame is many of those winter annual weeds I would have expected have germinated and developed pretty actively. We have a nice snow cover throughout much, if not all of the state. They're likely overwintering well, and I expect bumper crops that we're going to have to deal with in spring. So I want to bring that to your attention. What are some of these culprits? Chickweed species are some of those you need to be aware of. We have two main species, although there's several in Wisconsin, mouse-eared and common chickweed. Prostrate growth, opposite leaves. The mouse-ear can be very hairy, while the other chickweed species are not as hairy. Fairly easy to identify with the white flower. Really be on the lookout for this one. Shepherd's purse, this is one over the last 10 years I've seen really rapidly expanding throughout Wisconsin in many of our no-till fields. Easy to identify when it's flowering. It has those heart-shaped fruits that are present, white flowers. But also, we'll see this right when the snow melts, it'll be germinating right, or it'll be growing right away and have highly divided leaves. It's easy to identify as well. And finally, the third one I want you to be on the lookout for is pennycress. Some may refer to this as a crop. I would not call this a crop. I would definitely call this a large problem in a weedy species, and I expect lots of it. Easy to identify by having these wavy to serrated leaves that clasp the stem. If you crush it, it has a very bitter smell. Some say it's garlicky. And clearly easy to identify when it has fruit present because those fruits have that clear dime-shaped fruits that have a notch in the tip of them. So just be on the lookout for those three species this spring. There's a few others to be looking out for too. I expect it to be a bumper crop this year. The good news is they're fairly easy to manage, and they're fairly easy to manage with some of the tools that we commonly utilize. A wide range of products are effective and economical. Glyphosate alone or in conjunction with 2,4-D are really effective, and there's a lot of other products that are effective as well. Applications can be applied in the fall. So if you did your applications this fall, those are the most consistent, good for you. But we can still get really good results in this spring. We do have to be aware that as these weeds get over 6 inches tall, some of the herbicide labels will be in that 6 inches or less time frame. So we want to try and get them early versus later. Okay, so that's enough of my talk for my predictions. You can come and see me in April and May and tell me how wrong I am and that winter annuals weren't a problem at all. I'm going to now shift gears and really focus about how we can improve some of our perennial weed management issues. And we can do this with burn down treatments. There are effective options, but there's challenges associated with these in our northern climate, timing-specific challenges and weed-specific challenges. And really, these concepts really overlap quite a bit. So I'm going to kind of go through these and talk about these. The first thing I wanted to do, this was kind of an interesting exercise, I wanted to kind of talk about, well, what are the top 10 perennial weeds that we see in our corn and soybean systems in Wisconsin? So what I did is looked at some of the past surveys done over the last 6 or 7 years by Ross Recker and Nathaniel Fickett, and kind of classified those to come up with what are the top weed species that we have in our Wisconsin system. So as no surprise, common dandelions was the most common perennial weed species that we had. Had lots of quackgrass, yellow nutsedge, white cockle or white campion was another one, Canada thistle and field bindweed. Those were kind of the top 8. Some of the surprising species that you may not have thought of is white clover was really common in many of our fields, and that's one that we may not consider a weed. And volunteer alfalfa is one that we're seeing more and more of showing up in our corn and soybean fields. And then finally, plantain species and horsetail were ones that rounded up the top 10. So these are ones that we commonly see, although there are a range of other species as well. Well, when we think about managing these species, we have to think about, well, when are they present in this system? And these species emerge and show up all at different timings, as we'll talk about more later. And I want to emphasize that when they emerge and when they're actively growing is really critical to know in order to dictate how we're going to manage these species. We have some species that are actively growing early in the spring. And as I'll talk about, these are great ones to target for increasing control with some of our burn down treatments, like dandelion, quackgrass, even clover and volunteer alfalfa. These are ones that are growing really early in spring and even late into the fall, and we can really effectively target in our burn down treatments. But we have other species, such as yellow nutsedge, Canada thistle, our bindweed species, and horsetail, that don't grow actively during those burn down time frames in the fall and more towards that spring time frame. So those are ones that we really don't have as good an opportunity to control in our burn down time frame. So we need to realize that a lot of these results are going to be very species specific. Okay, so now we're going to kind of take a step back and go back into Weed Science 101, looking at how herbicides work to maximize control on some of these perennial species. In order to maximize control of perennial weeds, we need to get that herbicide absorbed into the plant, and then we need to get that herbicide to move or translocate into those perennial tissues. That could be roots, rhizomes, tubers, just depends on the species we're talking about. And I'm going to talk in a little bit more detail on each of these with reference to burn down treatments. So how do we maximize absorption of herbicides that we're applying in a burn down situation? Well, it depends. Are these herbicides going to be taken up by the foliage or by the roots? If these herbicides are going to be taken up foliarly by the leaves, we want to treat when there's as many leaves present to absorb that herbicide as possible, right? So that's really important characteristic to remember. And then the second thing we need to remember is we want to treat when conditions are conducive to allow for absorption of that herbicide. So what do I mean by that? Well, those leaves aren't drought stressed, the leaves aren't dead due to frost damage or something like that, and most importantly, that temperature is warm enough that absorption can occur. Temperature is a really important factor in herbicide absorption into those plants, usually temperatures above 50 degrees. Now, secondarily, if that herbicide is going to be taken up by the roots, we need those roots to be actively absorbing that nutrients, water, and those herbicide will be moving up with them as well. And we'll briefly talk on this, but we have a little bit more flexibility in temperature with that. So what do you think? What do you think how most of these herbicides are absorbed when we're applying them in a burn down situation, foliarly or by root uptake? Silence. Foliarly, right? So that's really what I'm going to focus on here. But we do have herbicides that can be absorbed by the root too. And those are some opportunities to increase control, as we'll talk about. So how do we maximize translocation of foliar applied herbicides? Well, we want to apply at the right timing so that that herbicide can translocate into that perennial tissue. The timing is very phenology and species specific, but really the two key timings I want to mention are that timing when flower buds to early flowering is one good timing, and then in the fall when green tissues are present and right before those plants senesce. Those are the two key timings to maximize translocation into the roots. Well, now, that can be some challenge with some of these species to hit that flower bud to early flowering timing, so that fall timing might work a lot better with some of our burn down treatments, as we'll see. The key thing I want to emphasize, though, is the worst timing to apply these for translocation is early in the spring, just after that plant emerges. That's when it's really a challenge to get a lot of that herbicide deep into that perennial tissue. So spring or fall, when we're applying burn down treatments, which is our most effective time frame? Experiments have been done in Wisconsin, other states throughout the region, and it's always clearly been shown, even when we're making applications in the fall, in the middle of November, as you can see with this example here, we're always getting significantly better control with fall applications versus spring applications. Whether they're herbicides that are only going to be absorbed through the foliage versus herbicides that can be absorbed through the foliage and the roots. So if you can get these on in the fall, that's by far going to give you the best results with the example with dandelion here. And it can be quite dramatic in some years, as you can see by this picture. So now the question is, living in Wisconsin, is how late in the fall can we go? This was clearly a great year this past fall to do some of these fall burn downs, so hopefully you were able to do that. But how late in the fall can really vary depending on what herbicide you use, what the weather's like, and the status of the weed. How resilient is that weed? Can it grow late into the fall or not? How stressed it is, how much leaf, how much leaf area is present. As a general recommendation, to kind of sum up all of these factors that I mentioned, we recommend that you can make an application when temperatures exceed 50 degrees Fahrenheit for several hours, the day of application or within 1 to 3 days of that application. So that's to counter many of these factors I just talked about. So when does that happen in Wisconsin? Any guesses? Pick a fall and it'll be guaranteed to be different every fall versus the other fall. So here's just some data to kind of show you that this 50 degree Fahrenheit time frame is really a good reference. This is some work we did on alfalfa suppression. We did it with a very low rate of 2,4-D, just 1 pint. And we did it at two different locations at 4 timings in the fall. That blue bar was a late September timing. That purple to reddish bar, I'm colorblind, so if I'm getting it wrong, tell me, is middle of October. The lighter yellow bar is Halloween, October 31st, and then that light blue bar is middle of November. And what you see that there's some variation between two of those locations, but that November time frame is where that control really dropped off, right? So let's look at the temperature and how that temperature changed in that time frame. This was done in 2008. What we see with these arrows that are green and that last one that's red are our 4 different application times. And as you can see, looking at the air temperature, that yellow bar is that 50 degree Fahrenheit time frame. And at that September timeframe, middle of October timeframe, well above 50 degrees Fahrenheit, good absorption of those herbicides, and as a result, effective control. When we got to that Halloween Day application, we saw it was pretty cold. That day of the application, it didn't get above 50, but we had some warm temperatures that day after. It was able to get above 50, and we got some fairly decent control. A little bit more variability, but decent control. But look at that middle of November timeframe. That's really where the roof fell out from underneath us, and we were much lower than that 50 degree Fahrenheit level. So as a good rule of thumb, if we can get to that 50 degree Fahrenheit level, we can get good control, and this experiment really demonstrates that at 2 different locations in Wisconsin. Okay, so how late in Wisconsin, how late can we go and still expect to see those temperatures above 50 degrees? What I did is I took this information from our Wisconsin State Climatology Office. These are maps that show you the average 30-year maximum temperatures over a 30-year time frame. And what we see on the left there is October. And what we see throughout most of the state, we can find in October days where temperatures will get above 50 degrees. Obviously, these are averages, so there's going to be time frames when we're below there. But if we look at all of those numbers, we see they're all 50 degrees or above on average in October. So likely well into October, we can have success. On the right side, we see November. And there, what you don't see is any temperatures above 50 degrees. And so we're really rolling the dice when we get into November. So I think October is a good time frame. Probably you can go late into October in southern Wisconsin and northern Wisconsin. You're going to struggle to get past middle of October in many years too. But November is really when it's going to be a challenge. But it's a crapshoot. We had many days in November above 50 degrees this year too. So it's highly variable from year to year. All right, so let's say you want to do a fall burn down treatment, but you can't get those temperatures above 50 degrees Fahrenheit. So what are some things that you can do? One of the options that we found is increasing the rates. Make sure they're within label, but increasing your herbicide rates can offset some of those low temperatures. We did some work with alfalfa again, and what we found, if we doubled the rate of 2,4-D, we were working in Roundup Ready alfalfa, we could get similar levels of control in controlling that alfalfa if we doubled the rate of 2,4-D in temperatures less than 50 versus higher than 50. So what we're doing is just adding more herbicide, so even though a smaller percentage is absorbed, we have more herbicide that gets into that root. The other thing that we found with a lot of our dandelion research has been shown that some products can still be root absorbed in those lower temperatures, even if we're getting poor foliar absorption. So tank mixing some of these herbicides like Autumn, Canopy, Express, these do have the ability to be absorbed by the roots, can offset some of those lower temperatures as well. So that's another thing you can do. Key thing, though, is we don't want to make those applications when the soil is frozen, but just when those colder temperatures exist. The third option is what? Wait till spring. And that's often what we do because of other activities. So if we are going to go in with some of these spring burn downs, what are some things that we need to consider? Number one item we need to think about is those perennial weeds we're targeting emerged? We not only need to have them emerge, but we need to have considerable growth so that they can actually, A, absorb that herbicide from having a lot of leaves present, and then two, hopefully that phenology is close where it can actually translocate it into the herbicide, into the roots or perennial system. So we have a tool called the weedometer that actually allows you to predict when emergence of some of these species is going to be and when flowering is in Wisconsin. You can just Google weedometer, or you can go to the URL that I see there. You can enter a lot of things. You can actually shift the location, so it can help improve the prediction if you're in northern versus southern Wisconsin. So just for the sake of time, I've kind of showed you a screenshot of some of the results with some of the common perennial species. And what you see here are these green bars. These green bars are the average emergence time of these weed species that I've highlighted there, with that's the range, with the green dot being the average. And then the yellow bars are the range of flowering of these species, with the yellow dot being the average. This was taken from the weed garden at the Arlington Ag Research Center work done there by Jerry Dahl in the late 1990s and early 2000 that can create these. But you can adjust the location and it will come up with an estimate. So what you see here is many of our species emerge in late March to early April, such as quackgrass, dandelion, white campion, and yellow rocket. These are really good candidates for a late April burn down treatment to be effective. They're going to be very well developed, have lots of leaf tissue, and be close to flowering. But some of our species, as you see, like Canada thistle and more importantly field bindweed and nutsedge, they're not even going to emerge until after the 1st of May. And so we really shouldn't expect to get effective control from our burn down treatments. So what are some other things besides emergence to consider if you're doing a spring burn down treatment? The really other important thing is to think about what those plant back restrictions are for the products that you want to utilize. Much of my talk is going to focus on glyphosate and 2,4-D. Why am I going to focus on that? Because in surveys, that's what the majority of people are utilizing, and they have very minimal plant back restrictions present on the labels. But a lot of other products are effective and can be utilized and have a lot of benefits, such as residual control, but we need to be really careful that we don't screw up some of those plant back restrictions on the label. So what I thought I'd do now is kind of show you one of our demonstrations that we did to kind of highlight some of the what happens long term with various spring burn down treatments. And this is going to highlight some things that you can vary to help improve your control. And what this is work that we've done with Dan Hyder with our IPM group here at UW on campus. He applied either glyphosate, 2,4-D, or combinations of the two as burn down treatments to some of his plots that were in continuous corn or soybeans. He applied them a little bit late, so they were May 20th, so keep that in mind. And then he planted these treatments 2 weeks after treatment. So what we did is we went in and took a range of measurements in these plots to look at both the initial and then the long-term benefits of some of these different treatments that I'm going to show you. What were the measurements? Well, we came back 30 days after treatment and looked at all the treatments, and all the treatments had 100% dandelion control. And this is really important, that showing you just using a burn down treatment, any of these, prevented that early season competition with those crops, which is our primary goal. And so they're all effective in that. But now what we're going to look at with our data is how can we improve some of that longer term control. And we're really going to make the assumption that that longer term control means we're killing some of those dandelions versus just suppressing that early season growth. How we collected that data was we didn't look at the cover of those plants, but we actually physically counted the number of dandelions that emerged. So if it was one dandelion that really looked injured but it was emerged, we counted it the same as a dandelion that was robust and actively growing, had a bunch of leaves. So we came in late July and evaluated this. And what we saw is on the y-axis here we have the percent reduction in the number of dandelion plants, and so we're comparing it to an untreated control. So we can see if we applied glyphosate at 3/4 of a pound, Roundup at 22 fluid ounces, in our corn or soybean fields, we were killing around 50% of those dandelions. So we are getting some long-term suppression, but again, we're probably only killing about half of those populations. The other half are probably the taller, older, more mature plants that we're struggling to kill. If we increase that rate from 22 fluid ounces or 3/4 of a pound to a pound, what happens? Now all of a sudden our mortality jumps up, almost doubles, gets around 85% in corn and soybeans. So that's pretty good. So that's one simple trick that we can utilize, just simply increasing our rate. Well, what happens if we add 2,4-D into the mix with a low rate of glyphosate? Well, again, we get a similar response that we do with increasing the rate of glyphosate. We're getting an increase in control to controlling anywhere between 80 to closer to 100% of those dandelions. Any guesses as to why we're seeing better control in corn versus soybean? Remember, these are continuous corn and continuous soybean plots. Soybeans, has a lot less residual cover. We're probably getting much more robust populations of dandelions in those continuous soybeans populations just due to less competition for light. And so that's my guess as to what we're seeing. And then we had a 2,4-D alone treatment, and we're seeing that combination of glyphosate and 2,4-D was also giving us some better control than the 2,4-D alone. We also did have treatments where we applied glyphosate at 3/4 of a pound and a pint of 2,4-D. We saw in the corn plots, we saw similar control to the glyphosate at 1 pound, but in those soybean fields, we saw a lot more variability in those results. I think it's due to it's right at that tipping point of effectiveness, and adding that more 2,4-D really did benefit it in the soybean systems. Are other herbicides available just besides glyphosate and 2,4-D? And these are the ones I'm talking about. And absolutely, they're available and they tend to be very effective, but their effectiveness is specific to the weed species and the time of application, and a lot of them have very specific restrictions in place that just really prevent me to talk about them in detail. Some, like we've done research with, like autumn, can be applied late into the fall and are extremely effective. Many of those that we utilize that are cost-effective, like autumn and basis, are really effective, but we still need to tank mix. Other products like 2,4-D or glyphosate are recommended to get that enhanced control. The good news is some of these other options are pretty effective, and they're generally very similar in cost. But again, they have very specific restrictions. Plant-back restrictions, some of them have very specific geographic restrictions that limit their use in Wisconsin, and some have rate restrictions. So read those labels carefully. So kind of sum things up, what are some tricks that we can do to increase our effectiveness on perennials with burn down treatments? Number one, scout those fields, know those weed species that are in your fields, and know when they're emerging and when they're sensitive to these applications, and time those applications based on their growth. And I gave you some resources to help with that. If you can, utilize fall applications when possible. Hopefully last fall you did a lot of that. This is a really effective time frame to do that. I know it's a struggle and it's a challenge. We have lots of things going on in the fall. If we have late harvest, it's hard to get it in every year. So take advantages of those good falls like we had that year. If we can't make those applications when temperatures are above 50, try to use some products that also can be absorbed by the roots. We see some benefits that can occur from that. And if you're going to apply in the spring, some options that you can do is first, know those species that you're targeting in the spring. Delay those applications as long as possible until you reach that optimum timing so you can maximize that movement of the herbicide into the perennial tissue. Increasing that rate of glyphosate with dandelions did show some benefit in increasing that, so that's one option you can look at. Adding additional growth regulator herbicides like 2,4-D or even dicamba if fitting in with the plant restriction is another good option to utilize as well too. But realize that some of our species are really not emerging during that time frame, like horsetail and bindweed, and really need to be managed in crop is probably your best solution. And that was that last bullet point that I said right there. So hopefully I haven't gone over too much time. I would like to answer some questions, but before I do, I want to mention that another option is just planting perennial crops. This is a great example of alfalfa in a dandelion infestation, and just having a perennial crop on the landscape can really do a lot of wonders for suppression as well. Okay, if I have time for questions before lunch, I'd love to answer them. Thank you.